Autumn 1944. Deep inside Germany, on the grounds of a secluded testing facility, a captured American tank rumbled to life. Its engine didn't cough. It didn't hesitate. It simply started. German engineers, men who had spent years designing and maintaining some of the most advanced armored vehicles on Earth, stood around the idling Sherman M4 with quiet surprise. They were used to tanks that demanded precision, adjustment, ritual, machines that groaned for the attention of experts. Yet here was a foreign design, built in a factory across the ocean, that behaved more like a dependable truck than a weapon of war. One engineer climbed inside, flicking switches and observing the rugged interior. No polished steel, no unnecessary complexity, just practicality everywhere. He tried to find the weaknesses they all expected. But instead, he found solutions. Solutions they had never considered. Outside, the thunder of distant Allied bombers reminded them why they were here. Germany needed to understand this enemy tank and figure out why it simply refused to break. Because on the battlefield, Germany's masterpiece machines were failing. And the Sherman kept rolling. To understand why a simple American tank could unsettle the engineers of a nation renowned for mechanical brilliance, we must step back to the beginning of the war, when steel, oil, and industry would soon decide the fate of entire continents. Before the conflict erupted in 1939, each major power held a different philosophy on armored warfare. Germany believed in precision, engineering excellence, machines that reflected national pride, technologically ambitious, even if difficult to produce. Their tanks would be powerful, feared, and admired, but they would also be complicated, fuel-hungry, and maintenance-intensive. The United States saw war differently. When Europe collapsed into conflict, America had few modern tanks, but U.S. industry had something far more valuable: the ability to scale. A manufacturing system built not on artisan craft, but on assembly line efficiency, repeatable, fast, and affordable. When America entered the war in December 1941, its army needed a tank quickly, one that could be produced by the tens of thousands. The answer was the M4 Sherman. It wasn't designed to be the strongest on the field. It was designed to always be there. Engineers prioritized standardized parts for easy production, reliable engines adapted from industry, simplified mechanics any trained crew could repair, fuel compatibility to match Allied logistics, enough firepower to defeat the enemy at typical battle ranges. Germany looked at this and saw weakness. They chased superiority. The Tiger and Panther were symbols of mechanical dominance. Thick armor, devastating guns. Commanders imagined decisive duels where one German tank could eliminate an entire Allied platoon. But those dreams ignored a harsher truth of war. Tanks spend more time moving, refueling, and breaking down than firing their guns. And on those brutal measures, reliability, mobility, survivability, the Sherman proved itself a champion long before any captured example reached a German workshop. North Africa, 1942. Shermans rolled into battle against German and Italian armor for the first time. Their performance surprised both sides. They were faster than expected, easier to repair in harsh desert conditions. Crews quickly learned to trust their machine, not for perfection, but for consistency. Where Panzers frequently required skilled mechanics to keep them running, Sherman crews could fix their tank with basic tools and keep fighting. And each month, more arrived. The United States was not building a weapon. It was building a system, one designed to overwhelm any battlefield with a relentless flow of steel and fuel. Germany noticed. Commanders demanded intelligence assessments. Reports spoke of a tank that wasn't elegant, but available in alarming numbers. Factories across the American Midwest produced Shermans faster than German engineers could redesign their machines. Soon, Allied offensives pushed closer to Europe itself. Every breakdown of a German tank cost more than time. It cost territory Germany could no longer afford to lose. By 1944, the Allies were landing in Normandy. The Sherman was now a familiar sound to German infantry and a growing problem for German leadership. But for German engineers, the truth would not fully set in until they finally got their hands on one. A captured Sherman was rolled into their testing facilities, including the storage grounds where Germany examined foreign armor. They expected flaws, shortcuts, inferiority. What they found instead was a new understanding of warfare. The Sherman wasn't built to be the best tank in a duel. It was built to be the best tank in a war. And that revelation would reshape their evaluations and their frustration. Because while Germany engineered masterpieces that struggled to stay operational, the American machine worked. Every single day. This realization sets the stage for the next step, when captured Shermans were torn apart, examined, and compared to Germany's own design philosophy. Their conclusions would be uncomfortable. As Allied forces pushed toward Germany's borders in 1944, the cracks in German armored doctrine widened into fractures. The Tiger and Panther, once feared symbols of engineering supremacy, were beginning to show the weight of their brilliance. Their engines strained under heavy armor. Transmissions buckled when forced to maneuver at speed. Suspensions failed under rough terrain they were never meant to endure. Each breakdown demanded hours, sometimes days, of skilled mechanics, tools, and replacement parts Germany no longer possessed in abundance. Ammunition and fuel deliveries became a gamble, not a guarantee. Even when a Tiger could destroy a Sherman from a kilometer away, that advantage vanished if the engine refused to start. German commanders knew the statistics. In many retreats, more tanks were abandoned due to mechanical failure than destroyed by enemy fire. Their most advanced weapons were racing toward the front lines and dying before they arrived. The Panther, introduced with hopes of overwhelming Allied armor, became infamous for its early reliability issues. Engines overheating. Final drive breakdowns under stress. High maintenance hours per kilometer. These weren't tactical losses, they were engineering defeats. Meanwhile, the Sherman's presence only grew. For every machine Germany refined, the United States delivered 10 more, each ready for battle the moment it hit the ground. This imbalance was not just numbers, it was philosophy. Germany aimed for perfection. America aimed for practicality. The difference determined survival. Captured Allied tanks trickled into German testing facilities. Engineers examined them with critical eyes. British Churchills, Soviet T-34s. Each gave insight into the enemy mindset, but none frustrated German pride like the M4 Sherman. Outside, Allied bombers thundered overhead, tearing into German industry. Each bomb crater in a rail yard meant a Panther waiting on spare parts would wait even longer. Each oil refinery destroyed meant fewer Tigers would ever reach combat. Inside the testing workshops, the Sherman sat quietly. Simple, reliable, undeniably effective. German engineers traced wiring and fuel lines. They inspected the transmission, robust and forgiving. They studied the engine, often based on dependable commercial designs. They noted how quickly key components could be replaced, how standardized parts reduced downtime, how logical the layout was for crew survival and efficiency. This wasn't engineering driven by pride. It was engineering driven by purpose. And purpose was winning the war. Reports circulated through the armored branches. Technical officers expressed reluctant admiration. Maintenance is remarkably straightforward. Fewer crew are required to keep it operational. It withstands prolonged use better than our own machines. They may have had superior individual tanks, but the Sherman was part of a superior system. A system that delivered fuel to every offensive, spare parts to every front, replacement vehicles without delay, training programs that kept crews competent. The closer Germany came to defeat, the clearer the lesson became. A war of attrition does not reward the most powerful machine. It rewards the machine that simply continues to function. The Sherman embodied that truth. Its greatest strength was not intimidation, but inevitability. As engineers finished their evaluations, many remained puzzled. How had a nation famous for consumer conveniences produced a war machine that displayed such ruthless effectiveness? The answer would come on the battlefield, where reliability decided life, death, and the ability to keep moving. And movement, in 1944, was the only thing between Germany and collapse. Now the story shifts from philosophy to the sharper angles that reveal exactly why this American tank kept Germany awake at night. On paper, German tanks often outperformed the Sherman. Thicker armor, bigger guns, more intimidating silhouettes, but those comparisons only mattered when the tanks were able to meet each other in combat. Reliability changed everything. The Sherman's engine was not a demanding specialist. Many variants used robust powerplants adapted from aircraft or commercial applications, engines designed to run for hundreds of hours without precision adjustments. Fuel lines were accessible. Cooling systems were forgiving. If something failed, a crew could often repair it themselves using spare parts that were already stocked across the supply chain. A Sherman could drive hundreds of kilometers without major failure. A Panther or Tiger, often dozens if that. Where German tanks struggled to start in cold weather, Shermans ignited confidently. Where German tanks overheated, Shermans maintained steady temperatures. Where German transmissions cracked under battlefield strain, the Sherman's drivetrain held firm. This wasn't luck. It was the result of design choices based on what war truly demands. Constant availability. Frontline soldiers quickly recognized the psychological power of a machine that simply kept moving. Sherman crews learned they could push hard, confidently. They could advance when ordered, not negotiate with their tank. They did not fear being left stranded behind enemy lines while their machine gasped and died. German crews, they often feared breakdowns more than enemy fire. Reliability meant a Sherman could always be part of the fight. More importantly, it meant many Shermans always would be. That alone changed battlefield math. Because no weapon is deadlier than one that shows up every time. War is not won by isolated duels. It is won by the side that can sustain operations longer, farther, faster. The Sherman's true genius was not in armor or firepower, but in the system that supported it. Standardized parts ensured that a component from one Sherman fit another perfectly. A transmission swap could be completed rapidly, often under battlefield conditions. A road wheel could be replaced in minutes. Crews carried maintenance tools because they were expected and able to fix their own tank. In the U.S. Army, recovery vehicles, repair depots, and supply convoys followed armored formations like a shadow. The goal was simple. German logistics envied such luxury. Their armored battalions often became trapped by their own machines, stranded without fuel, missing replacement parts, desperately waiting for mechanics, already overwhelmed by other breakdowns. Fuel quality mattered too. German tanks depended on high-grade supplies increasingly unavailable as the war dragged on. Shermans ran on gasoline widely distributed and reliably delivered. When German engineers opened the Sherman's engine bay, they were not impressed by what they saw. There were no exotic technologies, no finely tuned mechanisms demanding admiration. It was a machine any factory worker could understand, and that was precisely why it worked. Ease of maintenance multiplied the Sherman's presence on the front line, multiplied its threat, multiplied the psychological strain on enemies who could not wear it down fast enough. As German engineers studied those advantages, a more uncomfortable question emerged. A tank is only as effective as the men inside it. Designers in the United States understood this instinctively. Sherman interiors were laid out for accessibility and efficiency. Hatches opened wide, escape routes were simple, and ammunition storage was separated to reduce catastrophic explosions. When a Sherman was hit, it did not always survive, but often the crew did. Combat experience revealed that fireproofing measures, spacing of fuel and ammo, and internal design reduced fatalities compared to German counterparts. The brew-up phenomenon, where a single strike could ignite entire tanks, was far more common in Tiger and Panther models. German engineers studying captured Shermans noted this quietly, almost reluctantly. Survivability was not achieved through impenetrable armor alone, but through smart design, a tank that protected its human cargo, allowed repairs mid-battle, and gave its operators confidence to fight longer. For the Allies, this meant crews returned to battle more frequently. Fewer men lost meant experience accumulated, tactics improved, and morale remained resilient. Reliability combined with survivability reinforced a cycle Germany could not easily replicate. Shermans were not the fastest tanks ever built, nor were they heavily armored like the Panther, but mobility on varied terrain became a decisive factor. Suspension systems were forgiving. Tracks distributed weight evenly, allowing the tank to cross mud, sand, or rubble without becoming immobilized. German tanks, engineered for precision and raw power, often struggled under less than ideal conditions. Panthers bogged down. Tigers required flat, solid surfaces. Every obstacle became a potential mechanical hazard, a vulnerability that Allied forces quickly learned to exploit. The Sherman's mobility allowed combined arms tactics to flourish. Infantry and artillery could rely on armor support where German tanks could not reach in time. The machine was adaptable, able to respond to tactical shifts without requiring extensive mechanical intervention. German engineers, once proud of their masterpieces, increasingly recognized that battlefield performance depended not on theoretical superiority, but on consistent functionality under stress. Perhaps the Sherman's most insidious advantage was its sheer numbers. While Germany struggled to maintain one operational Tiger or Panther, the US churned out dozens of Shermans per day. Standardization meant production could scale without compromising battlefield reliability. Every lost Sherman could be replaced, often faster than a single German tank could be repaired or redeployed. This relentless supply of machines created an invisible pressure. Germany's technically superior but fragile tanks could not absorb attrition at the same rate. Combined with mechanical reliability, ease of maintenance, survivability, and mobility, the Sherman became a system designed for sustainability rather than individual brilliance. German engineers recognized this, but admiration was tinged with frustration. The angles converge on a single truth. The Sherman was not a flashy masterpiece. It was a practical, persistent, and resilient weapon, and that persistence was the foundation of its battlefield success. From this analysis, the story moves toward the climax, when these qualities were tested on the battlefield and in German testing facilities, forcing engineers to confront the uncomfortable reality of the Sherman's effectiveness. Autumn 1944. Normandy had been liberated, yet Germany clung to every inch of occupied territory. Allied armored divisions pressed forward, and the Shermans, simple, numerous, and relentless, surged in overwhelming waves. In the Bocage countryside, German tank crews operated their Panthers and Tigers with precision born of pride and training. Every maneuver calculated, every shot a potential killing blow. On paper, they were unbeatable. In practice, the battlefield had other rules. Sherman platoons advanced with astonishing resilience. While a Panther required hours of maintenance to stay operational, a Sherman that lost a track or suffered minor engine damage could be repaired on the spot by its own crew. Within minutes, it returned to the fight. German commanders began noticing patterns. Engagements that should have been decisive were slipping away. Tigers destroyed several Shermans in each encounter, yet their slower replacements could not arrive in time. Allied forces simply flowed past, consuming territory faster than Germany could react. The psychological weight was just as severe. German engineers and officers increasingly feared attrition. No longer was it only about tactical superiority. Every mechanical failure on their side magnified the enemy's relentless advance. Meanwhile, captured Shermans in German workshops revealed another truth. Engineers meticulously inspected armor thickness, internal layouts, and suspension systems. Each component seemed designed for continuous operation, for rapid replacement, for human survival. They tested engines at maximum strain. Nothing broke easily. A senior German engineer wrote in his notes, later found after the war, "This machine does not falter. Every test confirms its endurance. It is not perfect, but it works." The field experience matched the laboratory. Panthers and Tigers could win individual duels, but the Shermans kept coming, never missing, rarely failing, and always present. They could absorb losses that would cripple German units. In these moments, the American tank's true power became clear. Reliability, simplicity, and numbers had combined to create a weapon no engineering marvel could outmatch. The battlefield was no longer dominated by individual superiority. It was dominated by persistence. As Allied forces pressed further into Germany, the Sherman became more than a tank. It was a symbol of industrial ingenuity and strategic foresight. The German engineers' respect, grudging, reluctant, and unspoken, was growing. Even in the quiet testing halls far from the front, the truth echoed. Germany had built machines of brilliance. America had built machines that endured. And endurance was winning the war. The next part will intensify the climax. German engineers, direct evaluations of captured Shermans, field testimonies, and the moment they fully confronted the tank's effectiveness. Winter 1944-45. Deep inside Germany, captured M4 Shermans sat in carefully prepared testing facilities. Engineers, many of whom had devoted their lives to designing Tigers and Panthers, approached each machine with skepticism, expecting flaws, weak points, or shortcuts. What they found, instead, unsettled them. Engines started cleanly, even after hours of idle storage. Transmissions endured repeated stress without faltering. Tracks could be replaced in minutes. The interior was practical, organized, designed to keep the crew alive under fire. Every component was easy to access, easy to repair, and durable. Tests pushed the tank to extremes: rough terrain, steep inclines, extended operations under simulated combat conditions. Every trial confirmed the same lesson. This was not a fragile machine, nor a hastily constructed imitation. It was a purpose-built instrument of war, simple, reliable, effective. German engineers made notes, reluctantly impressed. Some admitted quietly that their own designs, though technically brilliant, were fragile. The Tiger could annihilate a Sherman at distance, but break down on a muddy road. The Panther could outgun any Allied tank, but stall if the transmission overheated. They compared specifications and field data. Sherman losses were heavy in combat, yes, but replacements arrived faster than German crews could repair or replace their own tanks. Mechanical failures were rare enough that the tank's operational tempo could not be interrupted. It was then that the engineers grasped the Sherman's secret. Its brilliance lay not in raw power, but in sustainability. It was engineered to endure, not dominate individual battles. It was designed for a war of attrition, not heroics. Some engineers spoke in hushed tones. "We built masterpieces, yet this simply works. How can something so simple survive where ours fail?" At the front, Allied forces echoed the same conclusion. Sherman after Sherman returned to combat, often with minimal repairs, reinforcing the notion that numbers, reliability, and practical design outweighed the prestige of superior firepower. Even during retreats, The Sherman's durability allowed units to withdraw methodically, preserving men and equipment. German forces, forced to abandon more advanced vehicles, began to feel the creeping frustration of attrition. The war was not being lost in spectacular tank duels, it was being lost because the Americans could maintain the fight when Germany could not. This confrontation between German pride and American pragmatism became a turning point in understanding armored warfare. Engineers, commanders, and soldiers alike recognized a stark reality. The Sherman was more than a tank. It was a system, a philosophy, a manifestation of industrial strategy that Germany had underestimated at its peril. By the time spring arrived, the Sherman had proven itself repeatedly, in the bocage of Normandy, across the hedgerows of France, and in the crumbling cities of the Reich. Germany's finest machines could no longer hold the line against the relentless advance of a machine built not to dazzle, but to endure. And that realization, bitter, grudging, and undeniable, led directly into the aftermath. Germany's armored forces diminished not because of single engagements, but because the Sherman's relentless efficiency reshaped the entire battlefield. Spring 1945. The war in Europe was nearing its conclusion, and the consequences of the Sherman's design philosophy were fully apparent. Germany's armored forces, though technically formidable, were outmatched not by individual skill, but by persistent availability. Where German tanks failed mechanically, Shermans continued to advance. Where German units were immobilized, Allied forces pressed forward with a relentless tide of functioning vehicles. The impact was both tactical and psychological. German tank crews grew wary of engagements that should have been favorable. Even a well-placed ambush could be countered simply because replacements were always nearby. Shermans moved in waves, their resilience frustrating commanders who had once relied on mechanical superiority to offset numerical inferiority. Strategically, the Sherman's presence allowed Allied forces to maintain momentum. Campaign after campaign demonstrated that the Americans could sustain attacks longer than Germany could defend. Battles were won not only by firepower, but by endurance. Each Sherman that survived a confrontation returned to the fight, reinforcing the front line. Casualty reports and field accounts illustrate the disparity. German Panthers and Tigers often failed before engaging enemy tanks, succumbing to engine trouble, suspension failure, or logistical shortages. By contrast, the Sherman's simple, robust construction meant fewer breakdowns, faster repairs, and consistently high operational readiness. The ripple effect extended beyond individual encounters. Units that could rely on Shermans for reliable support executed combined arms operations more effectively. Infantry advances were bolstered by armored presence. Artillery and air support could coordinate with a tank force that would hold ground rather than falter mid-battle. German engineers continued to analyze captured Shermans, but their conclusions were grim. Production numbers, simplicity, and battlefield endurance created an imbalance Germany could not overcome. Their finest tanks, though technologically advanced, were effectively neutralized by the Americans' logistical and industrial advantage. In essence, the Sherman's victory was not measured in spectacular duels, but in the silent, relentless functioning of thousands of machines, day after day, kilometer after kilometer, battle after battle. The scene now shifts to the second part of the aftermath, which will examine post-war evaluations, enduring lessons, and the broader implications for armored warfare. By the end of 1945, the war in Europe had concluded. German industry lay in ruins, and surviving armored divisions were scattered or destroyed. The Sherman, ubiquitous and resilient, remained a symbol of Allied persistence. Post-war assessments revealed just how decisive the Sherman had been. American reports highlighted its reliability, ease of maintenance, and mass production advantages as key factors in sustaining the Allied advance. For the Germans, captured documents and engineering analyses told a story of reluctant respect. Tigers and Panthers had dazzled on paper, but the Sherman had endured where their machines failed. In German post-war memoirs and declassified engineering notes, the pattern was consistent. The Sherman's simplicity and standardized design allowed for high operational readiness that Germany could not replicate. Crews could perform repairs quickly. Units could be replenished almost endlessly. The combination of reliability, mobility, and survivability transformed what might have been ordinary tanks into decisive instruments of war. The impact extended beyond tactical encounters. Germany's inability to counter a tank that could be replaced faster than it could be destroyed altered strategic planning. Armored doctrines were reassessed. Armies realized that mechanical perfection alone could not win a war. Operational sustainability mattered just as much, if not more. The Sherman's legacy continued in post-war armored design. Nations studied its principles: standardized parts, easy maintenance, reliable engines, and crew-focused design. The lessons of wartime production and battlefield endurance influenced tank development for decades, shaping the balance between technology, logistics, and practical combat requirements. Perhaps most striking was the psychological effect. German engineers, once confident in their sophisticated designs, were forced to acknowledge that a simpler, more pragmatic machine could outperform their own creations in the realities of modern warfare. The Sherman had not only survived the battles, it had quietly reshaped armored warfare itself. As Europe rebuilt, the Sherman remained a testament to the principle that engineering brilliance is measured not by complexity, but by effectiveness under fire. It had proven that persistence, practicality, and adaptability could triumph over elegance and raw power. This realization sets the stage for reflection, the final step in understanding the Sherman's enduring place in history. The story of the Sherman is not one of flashy victories or heroic duels. It is the story of endurance, of a machine that simply kept moving when others faltered, of a philosophy that prioritized purpose over perfection. In the chaos of World War II, the Americans understood that war is not won by brilliance alone, but by reliability, adaptability, and the relentless presence of men and machines ready to fight again and again. German engineers had mastered precision, power, and complexity. Yet they discovered that even the most magnificent tank could not win a war if it broke down before reaching the battlefield. The Sherman, humble in design and often underestimated, embodied a different kind of excellence: operational efficiency under fire, human-focused engineering, and industrial foresight. Its quiet, persistent effectiveness proved decisive, not in a single spectacular moment, but through the steady accumulation of functional victories across thousands of kilometers of European battlefields. Beyond statistics and technical comparisons, the Sherman's legacy lies in its demonstration of a broader truth about warfare, and perhaps about human endeavors more generally. Simplicity, reliability, and practicality often outperform complexity and brilliance when conditions are harsh, stakes are high, and survival is paramount. Its design philosophy reshaped armored warfare, influenced post-war tank development, and forced Germany to confront an uncomfortable reality: endurance can be more lethal than superiority. In the end, the Sherman's triumph was not celebrated in headlines or monuments. It was felt in the quiet continuation of advance after advance, in crews surviving battles that could have ended them, and in an industrial system that could sustain war when others could not. It is a testament to the power of persistent, pragmatic design, a reminder that in conflict, the simplest solution that keeps working often defines victory. The Sherman did not merely fight the war. It endured it, and in doing so, it embarrassed some of the finest engineering Germany had ever produced, leaving a lasting mark on history that continues to shape our understanding of machines, strategy, and human ingenuity.